Azure networking is another core product of Azure, and we'll be talking about some of the key components of Azure networking, starting off with Azure Virtual Networks. An Azure Virtual Network isolates and segments Azure resources within that network, but we can connect our VNet or virtual network to various other Azure resources, or we can also connect it to our on-premises environment. A virtual network will provide filtering and routing of our network traffic. Basically, it can be a traffic cop. And this next point is critical. By default, a virtual network is contained to one region. It cannot span regions. But if you do need to connect your virtual networks that are in different regions, you can do so using virtual network peering. You can also use a VPN gateway, which we'll talk about in a moment. Let's go ahead and take a look at a virtual network. In our example here, we have our virtual networks. And as you can see, the resources, which just happen to be virtual machines in these examples, can all communicate with each other. If we'd like to connect these two networks, we either have to use peering or a VPN gateway. Without this connection, these two networks will not talk to each other. I've mentioned a VPN gateway, and it can be used to connect on-premises to Azure over the public internet, or in the example we just saw, to another Azure network. When we use a VPN gateway, the traffic is encrypted, meaning nobody can see that traffic as it's traversing the internet. A key point here to know about Azure VPN gateways is you can only have one VPN gateway per virtual network, which means when you're building out an Azure virtual network, you have to be aware of this limitation. To get around this limitation, VPN gateways support multiple connections, but those number of connections is based on the SKU. In this very simplistic VPN gateway example, we can see our virtual network, which has our virtual machines as our resources in this example. We have our VPN gateway. Our VPN gateway will connect to our on-premises environment as well as allow our VPN clients to access our resources within Azure. Another critical component of Azure networking is the Azure Load Balancer. The Load Balancer will distribute traffic in, out, and within the network. It provides low latency and high throughput, meaning it's fast. And there are two types of load balancers that you can implement within Azure. There's the public and private load balancers. The public load balancer is exposed to the internet and manages internet traffic, whereas the private load balancer is internal and will manage the internal traffic only. Let's take a look at an example of that. We have our traffic coming in from the big bad internet, and it will hit our public load balancer. That public load balancer will distribute the traffic between our resources, again in this very simplistic example, virtual machines. The private load balancer will then direct that traffic to a couple of additional virtual machines that are not accessible from the internet. We also have another type of load balancer called an application gateway. And what the application gateway does is load balances web traffic only to web applications. And that is the difference between a load balancer and an application gateway. The load balancer can balance a variety of traffic types. The application gateway is web only. It can route traffic based on the source and destination IP address and port. And it will support URL-based routing, meaning the traffic is directed based on the URL. That's a very high-level overview of the application gateway. It can do much more, but we're not going to get into that in this lesson. Let's take a look at it in action. We have our application gateway, and we have our web traffic coming in because it's coming in on somecompany.com, so we know it's web-based. Depending on the URL that traffic is coming on, it could be somecompany.com/pics or videos. The application gateway will then send that traffic to the appropriate location internally, whether that be pics or videos. And the last component that I want to talk about in networking is the Content Delivery Network, or CDN. The Content Delivery Network are globally distributed servers that are used to efficiently deliver web content in the user's region. Really, what this means is that content will sit on an edge server that's close to the user. This content is cached to minimize latency, meaning the user will get the content faster. And we typically use the content delivery network when high bandwidth is required. For example, multimedia content. You do not want to be pulling a video from the other side of the globe if you don't have to. That is where the content delivery network comes into play. For example, let's take a look at what it'll look like to get multimedia without CDN. In our example, our users would have to pull the content from one server sitting in one continent, and this content really could be on the other side of the globe for the user. In the case of media, we know what's going to happen. It's going to buffer. When we deploy using the content delivery network, you'll notice that we have many more servers that are closer to the users. Therefore, now when the user pulls that movie or image, it'll be much faster. And those are some of the key core networking products of Azure.